Question number 1 in the related rates problem set says a rocket is rising vertically at a rate of 880 meters per second. So that is going to be our dH by dt, which I've shown here in blue. And it is when it's 4,000 meters up. And so the rocket is in a position of 4,000 meters up. And if a person observing the rocket from 3,000 meters from the launch site, so horizontally it's going to be 3,000 meters, how fast is the angle beta of the angle beta of elevation increasing from this observer? So what we need to first do is we need to relate this angle beta to the height, okay, because the height is what's changing. Okay, so we need to relate beta to height. So to do that, we're going to need to use trig. So we know that if we take the height over the horizontal distance, in this case it is constant, okay, although we could accommodate a changing horizontal distance, the height over the horizontal distance is equal to the slope, or tan beta. So there's our equation relating the height to tan beta. I'm just going to make this a function of height. So h of beta is equal to 3,000 tan beta. And we want to generate a d beta by dt. So we're going to first of all differentiate the h, so dh by dt. Okay, and that's going to be equal to 3,000 secant squared beta times d beta by dt. And there's what we want, that d beta by dt. So we need to know the the dH by dt. Okay, so I'm just going to plug that in. So that's going to be our 880 meters per second. That's going to be equal to 3,000 times secant squared beta. Now we could work out the angle beta by using inverse trig. But really we don't want beta, we really actually want secant squared beta. Okay, so we really want that. And secant we can actually just get from this diagram. So if I do Pythagoras, the hypotenuse value is 5,000 meters. And secant is really just going to be the hypotenuse divided by the adjacent side, or the horizontal side. So instead of finding beta, I'm just going to directly use secant beta, which is 5,000 over 3,000, and then we're going to square that. And then we can isolate the d beta by dt. So d beta by dt is the only unknown part of this expression. Okay, so then solving for this, I get d beta by dt is equal to 880 divided by the 3,000s here cancel out, and we have, oops, I should undo that, sorry. The 3,000s cancel out, and I end up with 5,000 squared. So I'm going to multiply by 3,000 on this side and divide by 5,000 squared on that same side. Okay, and then typing this all into my calculator, we can simplify some of this actually. I should really simplify this fraction. 880 times 3 times 3 divided by 5,000 times 5. Okay, so this works out to be looks like to be 0.1056, and that works out to be radians per second.